Hey, how are you doing? We got a lot of work on this one. There's a lot. So you might get sick of my voice. Yeah. Well, I mean, there's always captions. That works well. I'm sure some of you guys do that. Yeah, I'm pretty sure. Uh, so we're our focus is on a little bit more going towards object-oriented design and what that looks like. Because the whole reason for objects to exist is to solve problems by design. They do that inherently just themselves, but we also have other methods of relating them and working with nested objects, linked objects, all kinds of ways of organizing objects in different methods and representations with UML diagrams. That's where we're headed. So a lot of what this talks about is the components of design, implementation, testing, and some of that nature stuff. Definitely read into that. But I wanted to take the time to really give you some contextual information, or demo it within context. I guess it makes simple stupid simple, and then kind of mess around with graphic stuff coming up. So all this comes down to essentially the main topics is the static versus non-static variables and functions. That one's key. I mean, if you haven't noticed, main is static. There's a reason for that. Model composition and aggregation. Composition slash aggregation. We call in Java we say aggregation. Every language is just silly, but composition. So I'm going to use those interchangeably: aggregation and composition. But I know why they use different words, because Java has different capabilities for these different design concepts. And that's why different words are used, because there are some distinctions. We're not going to get deep into that. Describe and model the this keyword. So that's one that we're going to get into. And then, of course, the interface, what an abstract interface is. A little on enumerators. We're not going to hit it too heavy, and then eventually we're going to mess around and find out. And that's going to be with some graphic stuff, but that will be in another video. It'll be in the same module. So yeah, let's get started on it. Let's focus in on this stuff and start doing just some demo with static versus non-static variables and functions. And we're going to do that within the context of an object. And let's focus in on what that object will be, because eventually I want to give you an example of abstraction. Let's say that we have a user class that contains information about a user. And let's start there, and then we'll use that as a starting point for demo. Actually, you know what? We can use it somewhat here, but I might get a little too. I want to be simplistic. No. Let's not get too fancy. All right. we're going to have a new Java class called user. Put it in the same package. And then I'm just using this for plain demo, guys. And we will explore static versus non-static variables and functions. So let's start with a string called name, and let's go with a private. No, yeah, why not? Private string name, and then we will go with, and let's not get too fancy here, ID. Name and ID, very simple. I wonder because sometimes you can just have it generate the getters and setters. There's a way of doing it, but I'm not going to get into it. And this is actually a good time to go over this. And I think I've already discussed it before. So we can knock that one down actually right now as we peg through some of this demo. But I know I started out with static. All right, I'm not going to get off scope. We will use it though. I might be messing that up. I do need a constructor though. I need me a constructor. Actually, you know what? Yeah, what the heck with that. Let's do this in the constructor and overload the overload. You guys are going to do the get and sets. Well, eventually we're going to put that in there. So let's bring it back and finish it up. So, geez, I just want to be lazy today. I don't know why. Dang, what is it? Just one of those days. Mama said it would be days like this. Okay. What do we got? We got something that'll be clean, at least. Oh, this. silly you, silly. Okay. All right. So let's see. Oh. Sometimes I'm thinking Python, sometimes I'm thinking JavaScript, sometimes I'm thinking something else. Right, come on, be clean. Okay, all right. We'll do the gets later when we play with it. Okay, now static variable. Let's look at normal behavior first, and then I'll show you the different behavior with static. All right, so we're going to have a user called U1. I didn't put a constructor in there, but it should. It might not like me because of that, yeah. Yeah, okay. Yeah. Okay. Constructor. Good. Now we got to use the constructor from main. We got everything set up. The toString override. How do I do it again? I always get it wrong. I'll look it up here in a little bit. Let's get back to normal behavior. And what we'll do is we will demo with ID. And all I'm doing is setting this up so that we can use it as a basis for understanding. All right. Now we have the object. Let's look at normal behavior. And what I want to point out is that when we instantiate a new user, we're using the object as a blueprint to create new users that are on the heap. And what do I got to do here? Is it name first? Name 1, 0. Is that the way I do it? It might be just being stupid. Yeah. Oh wait, yeah, now I'm being stupid. Yeah, okay, no, okay, I'm not going to use that term anymore. I apologize right now. I'm sorry. Okay, yeah, I've already gone off to one of those. Oh, no. You do not like me. Okay, right there. Let's see what's going on with you. String int. Yeah. Isn't that the way I did the constructor? Oh. Okay. And the reason, and I know you're probably laughing at me inside. So, who puts a return type in a constructor anyways? Me. Okay. Yeah. So that's the joke that I love to have. Who's the person that does not like you when you're programming? Yourself. Okay. Are we clean? Good. Finally. Let's get to some normal behaviors. And then now let's do the toString override. Okay. So I'm just going to look it up because I've got too many languages in my head. Let's see what it is. Oh yeah, okay. Yeah, there it is. All right. Okay, that returns a string, so we're going to return, and let's do ID first here. I don't know. I just like that idea. That idea. Ooh, that one was dry. Oh no, I didn't say that. How do I convert to string in Java again? It's str in Python. I've got toString, shouldn't it? Yeah, that should be it. Something like that. All right, yeah, looking it up. Oh no, we use a static function of type integer that does the toString for us. I believe that's what it was when I looked it up. Where are you, little guy? There's the example right there. And that's a good example of a static function. Apparently the instantiated name of integer is, by the way, yeah, an integer is an object. Oh, what is the toString? Did I mess that up too? Oh yeah, I did. Of course I did. All right, and then what am I converting to string? Because integer doesn't know. It's just a static function. It doesn't know what it's converting. It just knows it's converting to the type integer. Or converting from the type integer. So we're going to pass it this.id. Okay, and then we add that with a space, and then we say plus this.name. That'll get started on something to work with and play around. All right, good example of a static use, but I want to show you what it looks like. And we're going to do that with the set ID here, or the ID here shortly. All right, now that we've got something we can test and work with, let's get into the meat. Let's first get your memory, print your memory. Okay, so let's get like three users. Okay. User 2, user 3, name 1, 2, 3, and then 1, and then 2, because 0 and 1, same thing. Let's see. All right. Do we got some clean? Beautiful. All right. Normal behavior with non-static variables is that they change. They're allowed to change. But static variables are allowed to change. However, they only go and change one place, one memory location. So they're always changing the same thing. So let's look at that. Normal behavior. So this is normal behavior. If I were to output user 1, 2, and 3, the ID would be 0, 1, and 2. So let's do that. System.out.print. We did the toString output, so we can do U1 and then do a shift home, Control C, Control V, U2, and U3. And don't get on that insert key. U2, U3, no insert key. No way, you're out of here, buddy. All right. All right, so we're going to get 0, 1, 2. That's what you're expecting. That's what you guys all know it's going to be. That's what we know it's going to happen. Here's our 0, name 1. Here's our 1, name 2. Here's our 2, name 3. Now we can do print line here, so it does new line at the end of each one. I believe that should work. Zero, 1, 2, exactly as we'd said. Okay. Now, if we change U2's ID to 999 whatever, it's going to reflect that change in its ID that we set. And it'll print with that new value. Cool. Now let's make it static. What's gonna happen? Oh, it's static. Static. Okay, so we're gonna go up here and we're gonna make this okay. Let's do, this is static variables. All right, I think that builds, doesn't it? Okay, now let's look at the behavior. And we're gonna do this in the debugger so you guys can see a little bit of what it is. All right. All right. Now let's go ahead and we're going to go down here. We're going to look down here. We're going to look at variables. We're going to step over and we're going to look at U1. I'm going to break it down so that we can look at it. And we see that name is name. And it looks like we've got this static variable in here that has the value 1 called ID. And that's for U1. U2 was created also. And it has the value of 1. Wait a minute. Let's back up. What happened? Okay. So I look at user 1 and it starts out, okay, user 1 starts out with a static value of 0. Okay, but now we're instantiating user 2. Boom. Okay, user 2 has a static ID of 1, which is what we sent it. But look at over here, user 1. Look at user 1. Its ID changed to 1. It's because a static variable is only one location in memory. It doesn't matter what user accesses it. It's beautiful. It's like a super global for objects. I mean, it can get scabby, but it's also a good tenet of design because it's so useful. Not only that, it's freaking fast and efficient. So if you want a super global in your objects, for every object, no matter what, make it static. And it'll only change, but once it changes for all users. So I'm setting all users' IDs to the previous user ID. And so now, when I do a U2.setID, U1, U2, and U3 will all have 999999 in it. And so when we see the print and our output, boom. That's your super global, but it's beautiful. Of course, a horrible example, but here's a good example. For a user, we need freaking fresh IDs. But what if every user needed to have knowledge about how many users total were on the system? What if that's something that had to have, the users had to have? And so with that, you would say total users, and you could uh, assign that value once to any user, and all users for your whole instantiation will change that value to the new total. And that's kind of a silly example, but that's one way I've used it actually. Or a running total for, like, maybe this is a shopping cart, and you want to have a full total of all shopping carts across your whole system. You can keep a hidden static in there. Yeah, that's design. Some of it's design. I wouldn't say to do that. It's got to make sense. But that's static, guys. That's static variables. Now, static functions is the same idea, except for it's the function that is the same, and the idea here is just like a static variable. The memory location is the same. With a function, you can't call it on its instantiated object. You have to call it on the data type definition. And that's the key difference. And it would be things for utility functions. So by design, you would use it for utility functions that you wanted to have available to all data types, or all instantiations of that data type, fairly easy, and you would make it generically accessible through the data type's definition name itself. So let's show you that next. Okay, so a static function would be purely utility. And what we could do is we could have it be where it does an operation, some kind of operation on the variable itself that is generic and utility based. And I'm trying to think of a good example in this context, but let's see. Let's get mangled name. Let's just be that simple. Get mangled name. So it's going to be doing an operation on the data type, but here's the thing: is a static can't. We've got to pass it what it's expecting to work upon. It can't just work on nothing, because it's separate from the actual. Yeah, it's loosely based with the definition of the object, but it's not part of the instantiation of the object. It's not instantiated. It's just a function kind of lying out there. So we got to send it a user to work upon. A user to mangle. We'll call it user to mangle. To mangle. Okay, that's the user. Okay, whatever. And then what we'll do is we would return some kind of process on the name, plus we would actually take and say to mangle dot set name, and pretend that this is some private function that is protected or whatever. You know, that's kind of the idea. You're given access to it through a generic way. And then let's see, set name to Mangle's name, get name. Well, is there a get name? Oh, we did not do a get name. Oh no, here I am. Should I do Mangle ID just because I don't have it? Damn. Okay, now let's just do it. Yeah, it's just a silly example. Get name. Okay. Return this dot name. Okay. That should be clean. Oh. Yeah. Okay, so there's a few things there, but that's okay. That's because we haven't finished that. So this one we'll call the get name, and then it will add it with just some silly. Okay. Oh, I never did a data type for that. That's all right. I was just giving an example. All right, here we go. Build. Okay, let's clean it up. Yep, missing the return. And actually, this should not be returning the string. It should be returning the object that was mangled. That's usually what a static function does within a library, is that kind of utility. So, oh no, user, excuse me, user. Yeah. Okay, now this function is special in the manner in how it's called. We can't just normally call it from user in the normal manner. And that's what I want to show you right now. Let's make sure that we're clean. Okay, we're clean. All right, let's go in and I'll show you how to work with this function that's static. And we go over here to our main. And you'll notice in the IntelliSense, when I bring up a user, like U2, I should not have a mangle. There's going to be no mangle that pops up. No kind of mangle whatsoever. So you notice that I'm using the instantiated name of the object. For a static function, you're using a generic function that's kind of just out there in the ether, but it's loosely tied to your object. You use the definition name of the object that it's defined in. And we defined it in user. So we use user. Boom. Get mangled name. There. User dot get mangled name. Okay. And then we say U1 is equal to user dot get mangled name U3. Let's see if that works. I don't know if it can work. We'll find out. Shoot. Okay. All right, run it. We should see U1 printing out with some weirdies. Do we got weirdy? We got weirdy. Your one is weirdy. Okay. So that's the difference on static functions. and static variables. That's how to work it within the context of objects. Okay, and JavaScript, everything's an object, so it doesn't really matter. I'm speaking when I refer to it that way. Other languages. All right, onward and upwards. Where are we at? Let's do this real quick. We are done with this. Let's do quickly this, a quick review on it at least, because I was using it. Do it within this context. Okay, notice here that I have U1, U2. I know the names of my objects. But if I'm in my objects runtime, like say I use this set ID, if I'm in that runtime, how do I know that this is U2, that it's named U2 when I want to refer to the object's data itself? This guy right here, the object itself's ID. And I can directly access that with the this dot operator. Now, notice here that I just did a return ID. Well, in this case, there's no confusion between the ID in this scope and the ID in the object scope. So if I took out the this dot in front of there, that would be a problem. Because it wouldn't know, because you'd just be signing ID, this ID to ID. And so the idea I use kind of, well, no, I use that term too much. I use an example. Does your finger know what your name is? I mean, my finger doesn't know that my name is Josh. It just knows it's attached to me. It's me. Me dot finger. Me dot finger. Me dot finger move forward. Me dot finger move back. This dot finger move. This dot finger go. This dot ID equals. Okay. All right. Where are we at? We are at right here. We might. This is getting. Okay. Composition and aggregation. We are there, and we're gonna knock off some of the others if we can. We might have a discussion about enumerators. Actually, we might go in there and generate an example and talk about it. Actually, that sounds like probably a good idea. Let's do that. All right, composition and aggregation. All right, composition, aggregation, same thing. Well, okay. Let's use the aggregation word, and if I slip, just, say booyah. Booyah! All right. Objects are composed of other objects, and in this case, this object user is composed of an ID and a name. Now, when we use the term aggregation, composition, we are more referring to things that we don't describe as primitive data types, even though Java's implementation of these are as an object. So when we're describing it, we're talking more in terms of your defined user data types, things that you've created and designed and implemented. And this is a perfect example of where the usefulness comes into for those capabilities. So you're no longer programming for the user, the end user, in a lot of ways. You're also programming for another programmer when you're developing with objects. So what kind of advanced thing would a user need, and that would be a passphrase of some word or a password. Now, of course, the implementation of the password, guys, is going to be where we get the password from the user, hash it, and then we compare hashes. So this example is not complete when I work with the password. Uh, Proper password techniques are with hashing, but we don't need to get into that. I'm going to give you an example because say we're developing a password game and our user is our player and we want to score them on the strength of their password. How strong is their password? And so what we could do is we could have an object called passphrase or password. We could have an object called phrase and another object called password, and then the user could have the password. And we can actually use the phrase for an interface, possibly. Yeah, let's look at it. Let's do that actually. Let's go up here and let's say new Java class. And we're gonna say password class. Okay. But we're not gonna hit that yet because a password class is gonna have a little bit more to it. What we're gonna do is we're gonna implement this phrase class that password class will be related to. And that's where we're going to actually start things out. So this we're going to leave behind for now. We will come back to it. So we're going to create another class called phrase. And now a phrase is going to have it's going to have a string, or no, you know what? Let's come back to phrase. I'm thinking I was closer with password being the actual data class and phrase being the interface coming up with this example. Let's go back to the password class and let's do this. Let's do string private. Oops, I'm being silly again. String keyword, and then the password is going to contain a string called p-word. Now what is going to be some password attributes, and that's going to be strength. And that's the reason for password class to exist, is to keep track of the password and its strength. And that's what the user is going to be composed of, is a password. And that's aggregation. So let's look at it in practice. How would I implement this in the user? Well, we could have the user with two password objects, one for input validation and another one for the hashed version of it. Let's just be simple and let's just do a private password object called password. No, we can't do that. What did I call the object? Password? Shit. Oh, excuse me. Yeah. private password. Uh, uh, user's word. User's words. User's word. Okay, yeah, that works. Okay, equals new password. I wonder if Java will let me do that. I think it will. I think I can get away with that. I think it'll let me do that. Yeah, usually instantiating in definition code space is not good. You would instantiate here. Actually, you know what? I'm so old habit. Okay. Now you see here that I've added composition, complex composition. Here's the thing is right here, I've defined the reference to it, but I don't instantiate it until runtime code. Even though in Java, you can cheat and do it. That's all right. That's fine. By the way, I should put a default constructor in here. And if this was C++, it would be a copy constructor, all kinds of other stuff. But this at least covers some bases when I want to be extra sloppy. Put some flag values in and instantiate the password. So regardless, the password is instantiated one way or the other. Now, of course, I would maybe want to add to the overloaded and the password a filter. And that filter would be for setting the password. And then I would not allow the password to be set unless it met a specific strength. And that's where we're headed next. So let's get into password and wire that up so that we can control the setting, the password, and the calculation of the password strength. Okay, and we're just going to wire in some easy breezy. So what we'll do is we will say password. We're going to do the constructor, the default, p-word equals nothing. And notice I don't have to use this here because there's no confusion. Strength is equal to 0. Okay, now let's do the overloaded one. Oh, that's really weird. Sometimes I do that. I do like some weird key sequence. Oh, because I'm used to, never mind. Okay, now this is going to be my overloaded one. Now the strength, we can't send the strength in. That has to be calculated. So that's not going to, there's not going to be a mutator for that. There's going to be a get strength, but there's not going to be a set strength. The set of password will allow the password to be set if it meets a certain strength. And that's what we're going to do for control of the password. This is the sort of thing that you would design for a website or something. So, password is going to be passed in, and we need a set password function that enforces all of that. So we need a mutator. And we will allow line 17 to run, that's fine, but we will guard any other setting of password. And so what that's going to be is bool set password, because we're guarding it. We want to return whether it's true or false, whether it happened or not. Maybe. We'll see how it looks, but I'm thinking that's probably a better way of going. Set password, and then here we would have string new p word. Oh, you know what? We can just use password. Oh, wait. No, we can't, because I'm an idiot. String p word. Okay, that's fine. We'll do this. And then we'll say if strength is greater than 75. And there would be other checks here, of course, guys. Okay, so then we would set the password. Let's see if this checks. Oh. No, it won't check because if it doesn't return true, then it's just going to by default return false. Okay. That's the guard. So we have composition and a guard. Now let's look at how to work with this composition within the user standpoint. We have a password in the user that has the ability to set the password. It does not have the ability to get the strength or the password. It's not going to have the ability to get the password. It's going to have the ability to get the strength only. So that's going to password is going to be mutate only with guard, no read access. And then get strength is going to have read access. And this is all design stuff, guys. I'm not saying this is the way you would want to do it. I'm giving you an example of aggregation and a loose kind of how it would go. Oh, I didn't need this dot in front of it. Okay. I think we got it. We are along. We are in the. Oh no, I didn't get. Oh no, we're not getting password. We're just getting strength. We're setting password, and we're getting strength. But do we have a set strength? No, we don't. We don't have a calculate strength function. But we can get one. And maybe I want to share this special strength calculator with other objects in my repo. And I want them to do similar things. And for that, we need an interface. Okay, but before we do, let's demo our aggregation. Let's go in here and let's use our inner class. Let's go to u2 dot. And what we have here is the ability to get. Do we have the ability to get anything? Set name, toString, get class, get ID, get name. We don't have any accessor for the password class at all, do we? Do we? Let's look inside of user. Okay, or not for, yeah, we don't have any accessor for this guy at all. Okay. User is kind of being in well, I mean, it's sort of the filter, but everything's gonna be done at the user level. So it would be when the user sets their password or sets up a new password, we would want to pass in the new password. We could do it by default here, that's fine. Here we are assuming that we possibly are creating a new password, but passwords are dependent. They're not, we've got to have a little bit of some back and forth with the user, so we can't just do it there. So that means that the user needs a set password function that filters down to that password object. So let's do that. Of course, you know, there's going to be a lot of other checks that you put in here. We're going to be doing the simple one. No password police out there, please. Please no. It's going to return a true or false. And then we're going to pass in the new password. Let's call it P-word. And then here's what we're going to do. We're going to say if user's word dot set password, P-word, return true, else return false. Okay, now that would be a pass-through. Okay, now we can also give direct access to user's word. Why are you being a stinker? Oh my goodness, I just realized that I was being silly. I got through all this with a one major alien error. This is Boolean, not bool, guys. Oh my god. Okay. Boolean. Do that in both spots. Okay, now we're gonna walk through it. Okay, there we go. We got set password. Now, as I was saying, we can have direct control. We can say a direct read control we can give. We can say public user's word, get user's word. return user's word. Oh, wait, no, this is password. Excuse me, password type. Okay, and then we're going to return that user's password. And then that would give us, you know, this way you could have a little bit more control by just allowing set password and allowing the pass to filter down. This you can allow for chained operation of the aggregated class. So what it would look like here in our main is you could do, you could go to u2 dot set password of u2, and then that would call the set password of the password object in it. Or you could go and you could say go to u2 dot get the password object, get user's password, and then set that password to p word, and you can chain it. I guess p word is not jump for joy. Joey. I'm just putting silly stuff in. You know what I'm going to do is let's modify this just for fun so we can get some granularity. Let's put in for the password strength for just here that if we're going to say if p word dot length is greater than 8, we allow it to pass. And of course, yes, there's going to be more checks there. In fact, that's where we're headed. All right. Now we've got set password working multiple ways. Let's test this stuff. Let's go in here and just run it. And we'll see the set user ID. It's no longer static, so it only does it for that one. Set password. Okay, so set password, it's going to run the user's password first. Okay, then it goes to its aggregated class composed object, and it's going to run its password. Then we're going to look at the password length. And am I allowing this? Yeah, because it's greater than 8. Jump for Joey is greater than 8. So it's changing the data that is composed inside of the user object, which is the password class. Okay, and then you can do it this way. See, it goes right to the password set password class, though. You see the difference? We're not using the bridge. We're going right through it. We're making the bridge. We're making the damn bridge. Oh, okay, yeah. That's cascading. That's that's the whole reason for Java to exist, and some of the higher level C++ is capable of it. It's beautiful. All right. That's enough for now. Up next is, what do we got? We got aggregation. Now we just got interface to go. Interface. And we're going to get squiggly. Gonna have to get squiggly as we come to an end of this. I know, I'm sorry, I apologize in advance, but it's gonna happen. Yeah. Hey, you can just turn off my voice. That works too. I bet you the CC comes up all right. I mean, I try to use it. Okay, I'm done. Let's continue. What is an interface? Oh no, it's too much. All right, let's get into it. Well, let's think about an object as a box. So let's think of this as our user object. Our user, and it has, you know, name, ID, and it has a password. Now you can show aggregation this way, and your book with the arrows. I'm not going to get into the arrow UML stuff, guys. That's for, you know, plenty of stuff out there. And let's see, and of course, yeah, we'll get to it. Password, name, ID, and then the next one is an interface, because we have this password class. And password is part of it. Okay, and actually let's call that password, and this is actually P word, or whatever we called it. It contains that string. What did we call it? We called it that one we were coming back to, but I think we dropped it. We went with password, P word, and then strength. P word, and then strength. Okay, that's P word and strength, okay? Just P word and strength. We're putting the data inside a password, all right? Yeah, I've had it with that thing. All right, this is what we've been working with. We have a password in there. So we've got some relation here, aggregation. And we want, let's say that we want something over here, and I'm just going to call it literally an object that we call something. Let's just describe it as something. Doesn't matter what it is. And let's say that the behavior of calculating the strength of password, you want to share all that strength calculation behavior with something, so that you have only one code base that you have to work with, essentially with a blueprint all laid out between the two. And we call those, in multiple languages, comparators. Comparators. Say it 3 times. Comparators. Oh my gosh. Comparators. It's how we compare things. What things? Strings. Objects. Are they less than, greater than? When we do lexicographical comparisons for comparing one string to another to see if it's alphabetically in order. Any kind of comparison between items that are not the same data type. So how would we blueprint that behavior across different data types that don't relate? And that's one reason why programming languages have comparators. Look them up. They're out there. They're already implemented as interfaces. That's how they're done. So an interface is a blueprint of behavior. It does not. It does not snapshot a blueprint of data. Only behavior. Uh, Functions. Yeah, functions. And so your interface. Okay, let me back that up. Let me back that up. Interfaces can hold data, but the data should make sense for the utility. And in fact, I mean, there's specific restrictions that you have to have for an interface. Well, you know, the data has to be static inside of them. That's the way the that's the way the design works for the relation, because they're not, an interface is not designed to have mutability. It's designed as a contract. It doesn't hold data. It's behavior contracts. All right. Let's look at what an interface would look like for a behavior contract on determining strength between different related data types. And we would declare that, in fact, let's bring up an example. I'm going to grab out an example and throw it in here. Now we could just create another Java object and convert it and make it an interface with text, and with just a Java class, and use the interface syntax and semantics. But we got a nice little object, nice little thing here that says Java interface. So let's go with that. Now this one's going to be password police. Okay, this is going to be, and again, you can just create your own object file. It's just a Java file, and put the interface keyword in front of it, and you got your interface. Now, what this is going to do is this is going to describe behaviors that anything that implements this will subscribe to, and that way, if we want to process different data types all together, it would allow those behaviors to be different. I'm going too far. All right, that was too far. Let's go back to this then. All right, let's go back to this. We have a list. Let's say we create one big list. And we put users in there. Users, user 1, user 2, something 1, something 2, something 3, user 3, something 4. Let's call this master list. Master list of all objects of user type and something type. And let's say that we want to sort this list based on the password strength, because this is going to have, this something is going to have strength attributes. It may even have a password in it. And we may be using its strength. In fact, let's refer to it as that. Password and strength. Just like password. Same thing. But it's in a whole nother object called something. And this is called password. It could be in another object that we use inheritance, and we call it password. Password. I don't know, FBI password. I don't know, like super strength, super password, whatever. And then we have the same P word strength, and we have a list of super passwords, or those are on the list. And we want to process and sort all these items by their password strength. We need a common behavior. We need a common behavior, a contract. And what that is the signature of the function has to match. And as long as the signature of the function matches in each function, the contract is complete and the binding can happen. All right. So, what does that look like? Because you would have a sort method inside of this list that would call the strength method of each of these guys. And the strength method would return different values, but it would all be based on a calculated value or the contract of it. So you're going to be calculating different strength values for password FBI, for something, for a password. That's part of what the interface allows, is not only for you to have a contract of differing data types with a behavior, but also differing behavior of that as well. So we can have different strength methods that calculate strength differently for the P word strength versus the password FBI strength. Because the implementation of the strength function is up to the class that implements the contracted function. And then we can treat them all together in one basket of happy FBI users, something users, whatever. And we're nice and efficient and running well with good design. Okay, and that's an example of a little bit of, it's not clear, of polymorphism, but let's actually do this. So what does strength in a password look like? What is the function that we're going to implement that is necessary that these objects need to actually have? And I would believe that it would be a set. I think the get strength is just going to be a pass through for the data. So the actual calculate strength function is going to be used within this design. So the contract would be the calculate strength function that determines whether you should allow the password to be changed or not, or whatever. So what we'll do is we're actually not going to be using phrase. Let's get rid of that. We could have used it instead of password. That's what we could have done. But we're not going to. There we go. Be careful when you do that in NetBeans, guys. I've had it delete my whole project. I lost 6 months of work. I shouldn't have done that. Should have done it in the folder. Yeah. NetBeans is open source, guys. Yeah, sometimes stuff happens. It just stalls. Stuff happens. Make backups too. All right, password police. What is it going to do? Calculate strength. What is it going to return? It's going to return an integer that's going to represent, no, let's make it be a float. Let's be more, no, integer is fine. Int, it's going to return an int, calculate strength. Now, since this is a contract, that means it's not going to have any knowledge of the instantiated data within the object itself. And it doesn't really matter as long as it fulfills what the contract says it's supposed to fulfill. And that is with the function signature, because this would be used as the function that sorts it as a comparator. Okay, now let's look at the next bit, and that's going to be implementing this. We may have to flesh it out some more, but let's go to the password class. And if we are going to have a password class, we want it to implement the password police. We're going down, dude. We're going down. Hands up. Hands up. Implements. Now, I might be getting this wrong. I might have to look this up. Implements. What do we do? Implements password police. Okay. Okay, yeah. It doesn't like that. What did I do wrong? Let me think about this. Yeah, this isn't Java. That's Java. Oh, I think I forgot something key. And what do we got? We got error password is not abstract and does not override abstract method calculate strength. Ooh, we're not following a certain contract, are we? No, because we're saying, oh, I'm gonna follow you, Mr. Policeman. I'm gonna follow you. What do I follow? What do I follow? Let's see. What do I follow? I follow. Oh, I got to create a calculate strength function and return an integer. Okay, let's go do that. Let's go do that. All right, Mr. Man, I will follow your rules. I will. But this one's special because it's got to be an override. Why does it got to be an override? Okay, I'm going to get to that. Oh yeah, we're going to talk about why it has to be an override. Is it override? Oh, I always get that wrong. How the hell with you? I'll figure that out later. Here, let's do this. Int, what are we doing? Calculate strength. That's the problem with snake convention. Calculates strength. Okay, now I'm getting stupid. All right. Okay, that same signature, and we're gonna say, and let's do this. I did it again. No, don't do that. Okay. Okay, so we're going to just do a simple a little bit of some granularity for calculating the strength in just as for demo to reduce the time. Okay, so we're going to do this. If it's greater than 8, return 100. If it's only greater than 4, return 20, else return 0. Okay, just some granularity. Notice I'm doing and of course this would be different, guys. So this would be different for this data type, for the password data type that I'm creating. So why the override? Well, jeez, I'm having problems. Oh no, which brings me to a kind of a, well, it's an interesting thing with Java and interfaces. They want to enforce proper naming conventions for interfaces. And so that means that calculate strength should be with an uppercase S here. And that also should go down to here. So I'm getting all kinds of Java police issues here. I wonder how they're doing it. I wonder how they're enforcing it. Okay, and then, all right, that's simple change. All right, now what's the problem? Okay, we got a few more little issues. Let's get down to why you did not like me today. Oh yeah, we know it's been getting too long when we forget silly things like this. Since the strength calculator is going to be shared amongst classes, the interface has to be public by default. So that means that the function has to be public. Did I do that? Let's go. The get strength function. Ooh, it's not public here. Is it down here public? No. Ooh. Big baddie. Oh no. That's a big baddie. Oh geez. Okay. The interface is public. That's good. Okay. Phew. Alright. Now what do you... Oh, yeah. We gotta match the interface. And the interface had to be public. So now what are you yelling about here? Still got it override. Did I get my syntax wrong? Alright, you're probably laughing at me. Alright, calculate. I finally found it. I am my worst enemy. Ta-da, ta-di-la, ta-di-la. Alright, contract implemented. And now we can instantiate passwords or users with a password. And the password, when we create a password, it's going to follow the contract. So when we set the password right here, we got to say if calculate strength. And since we're overriding just matching the signature, it's totally cool that we're using our instantiated memory for it. So it's kind of just a generic function that we're matching with everybody else that's going to be in the pool. And we can deal with the function separately on our own, dependent on the data type. So we're going to say here that calculate strength. Let's do the this is the calculate strength for this one, so this is actually good. This is fine. But we need to call calculate strength here. If, and we'll only allow it if calculate, and remember this is generic, so we're not doing this dot or anything. Calculate, well, yeah, we could do this, yeah. Probably, maybe. You might want to experiment with that. Calculate strength, boom. If calculate strength is greater than 20. And then everything I think falls to that. We can have our granularity, our granularity in the calculate function that's generic, that follows a scheme that can be used if we wanted to sort these in some way with another pool of different data types, but are similar in some manner by design, so that we could share the behavior. So then how would this look at that level? I think we've got it all laid in now to create some passwords. And we're already doing it. Let's look at the constructors though. I think we're good there. The constructor, I don't want to really be able to do anything to the memory. I want to pass it all through guards, but I think this examples getting a little lengthy. So let's pull it back in and run it through its paces. Every time a new user is made, let's run it through. Okay. Step into. Set name there. New password. Step into. Boom. Just default stuff. Boom. Okay. That's good. Okay. We get all the way down to here to set ID. That's fine. But when we get to set password here, go into there. We call in the inner password. which is the user's word, and it's going to calculate strength. And then we're going to decide if it's strong enough, and it's going to return false, that, oh, that one wasn't very good. If we look down there, Jump for Joy didn't pass for some reason. We can set a breakpoint there and run this again and look at that. What are we looking at? Did it come out right? Is password length appropriate? Add a watch. Okay, change that. Length is 0. So is that appropriate? And trace it through. So is 0 appropriate for length? I don't know. Let's look. No. It's not. All right. One more thing. So remember I was talking about how you could actually grab data and look directly at it and have a little more granularity within the object that you're overriding this function for. It's not necessarily a good thing, because obviously I can't calculate the strength on a password I haven't set yet. It's kind of hilarious, actually. I'll laugh at that one. And that goes to the generality of the way these functions should work, I guess. It'd probably be better to pass what is trying to be changed. And in this case, we're going to do it really easy by being ridiculous, because I've already put in pword.length here, and pword.length, but I didn't add that. Now if I wanted, because what it did is it went to this .pword.length, obviously, not the one I want to examine. So I built that whole function with the idea of implicit memory, and went beyond even thinking about more of the utility. So that's going to have to change. That's okay. Let's go in and do that. That's fine. Yeah. Pretty easy. We got everything set up. All we got to do is have it pass, or what are we doing now? We're now passing the P word in. And that happens over, let's see, where does it happen? Not here. That happens right here. That's what we're going to actually end up doing. But now we got to update the contract. That's going to be in the interface right here. So now that needs to be a string. contract's updated. We already implement that. We updated the implementation of the contract. Now we're properly checking the local memory passing in, generalized. And then, and of course, you could do it the other way as well if the context fit. So it's good for demonstration, at least. So now we can make a change of the password based on the password being proposed, and if it's greater than 20, allow the change, and we're good. And this could be a sort function that returns true or false with a less than, greater than. Okay, now let's test it out. I think it's ready. See if it cleans, because I'm definitely ready for it to be done. I don't know about you, but it's been a minute. Okay, well, let's do this. Okay, step into set password. Okay, pass the password, and what we're passing is not going to be 0. It's going to have a password length of 11. Oh, I'm so funny. And then this is going to return that you are good. Allow the change, and then it passes through. And again, comparators, this would be using a sort, and you would implement it in your own way. As long as you match the signatures, you can use your own data inside. Sometimes you have to do a data pass-through. In this case, it matched the context of what the task required. So how does that come in at the full scope and kind of bringing it back to that top-down scope? What we did is we instantiated a password object and ran the strength function. We did not put it on a list where we told it to make a comparison or do something based on that strength. And that's the next step of working with interfaces. You could use it for sorting, and that's often what they're used for. So then that way, the sorting mechanism or the strength would be called within that pool that was making a decision based on a behavior strength, but with differing signatures of data type or object. So you match behaviors within a scope of a pool of all kinds of different types of objects. And that's very useful in computer science. It's how things are done, essentially, in a lot of ways. Because then you can implement what's called dynamic binding. And that's where interfaces become necessary so that memory issues can be overcome. And that becomes a lot more apparent when you're working at a level, a multi-threaded level, stuff like that. So anyways, yeah guys, the last thing is enumerators, and it's been long enough here. Let's just hit it up with, actually, I'm going to come back with a simple example, and we're going to talk about it real quick. And I want to clarify some importance of enumerators with an example, and then leave you to it to play with it. All right, here's an example of an enumeration definition. What an enumeration is it's a breakdown of switchable uh, values that essentially narrow down to Monday, the first from the list from beginning to left to right. Monday and 0 are the same thing. Tuesday and 1 are the same thing. Wednesday and two are the same thing. The problem is we found ourselves having to number things to assign attributes, but here we are using all these numbers, and they have any they don't map into any sense. So there's a lot of technologies that where you implement their libraries and stuff, they will have switchable flags that you can share and work with as part of their software development kits, where you use a lot of enumerators to work with that technology. It's a common thing, and the reason why is because it's easy, it's human accessible, it's it's fast, and you can use switches on them as well, which makes it even faster. But I mean, I know we got Java, we don't care about speed. Fine, all right, yeah, that's fine. I get it as well. I'm there with you on that. Yeah, I just want to get it done as well. All right, so you can just quite literally take Monday and replace it with 0. Take Tuesday, replace it with 1. And you have essentially the same thing, but it's done at a lower level where we don't have to deal with it. It's incorporated within the day enumeration, and it's in a box. It's a data type in and of itself. So put a little time into that. I think we've had enough with this. All right, guys. Thank you. Until next time. Bye.